So we're going to do a little kind of a mini lesson on solving proportions. This pops up in lots of Workplace 10 lessons, and I think it's a good thing to kind of refresh our memory on how to solve proportions and what that can look like. And so basically what I want to do with you is identify, well, if we're looking at, especially since we're doing so much with equivalent ratios and working through and looking at that equivalency piece, just want to kind of remind you that when we look at equivalent ratios or equivalent fractions, if you want to call it that, because that's the same thing, any fraction can be equivalent to another, provided that you basically are multiplying it by something top and bottom. So you're essentially multiplying it by a value, and it's the same value, top and bottom. So in this case, if we started with a fraction of 3/4, and I multiplied the top and bottom by 2, that would mean I would get a fraction of 6/8. So 3/4 and 6/8, they're equivalent ratios. Okay, I could take 3/4 times it by 3, top and bottom, and I would get 9/12. So 3/4 and 9/12 are equivalent ratios. So we start to see all of these equations or ratios that can be equivalent. So it doesn't matter what number I pick, any number, as long as I multiply it to both the numerator and the denominator, I will create an equivalent ratio. Well, a proportion is just essentially looking at putting an equal sign in between those two equivalent ratios. So in this case, I look at this and say, oh, 5/7. Well, 5/7, what would I have to multiply the top and bottom of 5/7 by in order to get 15/21? Well, in that case, all we did was multiply top and bottom by 3. And I got an equivalent ratio. So by putting in this equal sign, that's all I've done is actually created what we call a proportion. So a proportion is just simply basically taking two equivalent ratios and setting that equal sign in the middle of it, just to show that they are equal. Well, sometimes what we do is we need to solve a proportion because we might not have both fractions set up with numbers. We might be missing a piece. We might be missing the numerator, we might be missing the denominator, but essentially what we're doing is we want to know what value could I put in here so that I would create two equivalent ratios. So in order to do that, we'll do something that we call multiplying across. We're going to cross multiply across our equal sign. So it's essentially looking at corner to corner, we're going to multiply. So we're going to take the n and we're going to multiply it to the 22, which 22 times n just gives me 22n. And I'm going to set that equal to what I cross multiply the other way. So in this case, I've got the 15 times the 8. So now I've set up just a basic equation now that I can go ahead and solve. So in this instance, I can figure out, well, what is 15 times 8, which gives me 120, and that equals the 22n. So now solving an equation, well, 22 times the n, that's multiplication that's happening here. So if I want to get the n all by itself, that means I'm going to divide the 22 away. So I divide 22 away from both sides. So I'm going to take that 120 and divide it by 22, which in this case, I'm going to get n then, because 22 divided by 22 gives me 1. So I'm going to be left with an n is equal to 5.45. So that is the value that would need to go up here in order to make both of these fractions equivalent. So same thing goes, doesn't matter where your variable shows up within your proportion, you set it up the same way. Sometimes people would like to always start with that variable piece first, that one, whatever that crossing, cross multiply piece works out to. So in this case, maybe taking that 6 times that x, which would give you 6x, and then setting it equal to the other way. So which would be setting it equal to the 2 times the 30. So in this case, 2 times the 30 is going to give you 60, and you've got 6x on the other side. Again, trying to solve for x. So because it's being, the 6 and the x are being multiplied, I'm going to divide the 6 out, and I'm left with x is equal to 60 divided by 6 is going to give you 10. Honestly, it does not matter which way. I can go ahead if I wanted to do this and say, if you're used to just going from doing this first cross piece first, which would mean, hey, I'm just going to take the 2 times the 30 equals, and on the other side, I would just have the 6 times the x. So the only difference is it just changes placement of where your variable is. Your process is still the same. You can still isolate that variable, and you're still going to get a value of x equals 10. So either way, it's not going to change things. Okay, so let's look at a couple more just to kind of practice with that. So same thing. I can cross multiply and say that's 8n, and I've got the 2 times the 12. Well, 2 times the 12 gives me 24, and that equals the 8n. Again, dividing both sides by the value that's in front of that variable. So dividing by 8, I'm getting n is equal to 3. And then the last one, same thing. I'm going to take that 5 times the h. So 5h is equal to 4 times 14. And 4 times 14 is 56. And that equals the 5h. And I'm going to divide both sides by 5. And I'm going to find out that 56 divided by 5 is giving me 11.2. So this is a process that we're going to end up using quite a bit throughout this course. So this is kind of a good kind of a refresher for you as we're moving through this unit, because we will use it in this unit in a couple lessons. Okay, you can go ahead and do some practice on that, and we'll see you next time.